Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at the highlights of aluminium. And this is one of the group 3 elements which we said, of course, is going to be displaying some unique characteristics from other members of boron, gallium, indium, and thallium. And of course, we had decided that apart from boron, the other members are going to be displaying metallic character. And then the formation of various compounds, we're going to see them also displaying specific characteristics which are either going to be distinguishing them from other members of the group or creating similarities. Now in this particular discussion, therefore, we're going to look at the halides of aluminium. And in a particular case for the fluorides, we're going to see that the fluoride of aluminium is going to be forming this specific compound which is going to be having some ionic character. And this case, we had in our discussion on the structure of course, structure and bonding. We had said about the various forms of bonds which are going to be created. So we're going to have ionic bond, covalent bonds, and other bonds which we are going to perhaps discuss, or we have already discussed in some of our videos. And in this case, for ionic character, of course, this is going to be having this specific form. And we are going to expect this specific, of course, a halide of aluminium to be a good conductor of electricity in molten form, since this is going to be a ionic form, and therefore that's going to be a good conductor of electricity or current in its molten form. This is one of the characteristics of these halides of aluminium, and by contrast, we're going to see that other halides are going to be forming molecular species. For instance, if we have an halide of aluminium of this specific nature, so we shall have a general form for this specific aluminium. So we're going to have this particular halides being given for chlorine, bromine, and iodine, which are going to be displaying this, of course, molecular species being given as such. Now, in our last discussion on the concept of boron, I said that it's going to form a center 2 electron bond, which of course distinguished it from other members, of course, which we had said for gallium, aluminium, indium, and thallium, which displayed metallic character. Now in this particular case, we're going to look at this specific structure, and for the general case, we are going to have this, particularly for the chloride. We can just give an illustration for this one. We're going to have these 2 aluminium central atoms being bonded to the chlorides using that particular structure. And in one of our discussions, I've talked about the dimer of aluminium, and therefore this is going to be forming this specific species. Now this is going to be the central atoms of aluminium are going to be sp3 hybridized, being given as such. So therefore this is going to be forming this kind of bonding of hybridization, which is going to be the sp3 being experienced by these 2 atoms of aluminium. Now the halides of aluminium are going to be very reactive in nature, and we're going to see that they are going to form a strong or reactive Lewis bases, or Lewis acids in that specific case. Sorry for that. So they are going to form a strong or reactive Lewis bases, which are going to be in form of these specific halides. Now, of course, we're going to look at the reaction of some of the halides and some of the uses which, of course, are going to be relevant in our day-to-day applications. And then, of course, that's going to be assisting us to end up in this particular discussion on the concept of the reaction between aluminium and the group 7 elements. So that is it for now, guys. Kindly check our description boxes for various links of other similar videos. And also subscribe and engage us in the comment section for more discussion on various topics in science and mathematics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.